Myself K. Pravalika. My dish number 212H1A3072. Now I am discussing about common modeling techniques. First one, modeling webs of relationship. Apply use cases and scenarios to drive your discovery of the relationship among a set of abstractions. In general, start by modeling the structural relationships that are present. These reflect the static view of the system and are therefore fairly tangible. Next, identify opportunities of generalization, specialization relationships. Use multiple inheritance springly. Only after completing the preceding steps should you look for dependencies. They generally represent more subtle forms of semantic connection. For each kind of relationship, start with its basic form and apply advanced feature only as absolutely necessary to express your intent. Remember that it is both undesirable and unnecessary to model all relationships among a set of abstractions in a single diagram or view. Rather, build up your system's relationships by considering different views on the system. Highlight interesting set of relationships in individual diagrams. Interfaces, types and roles. An interface is a collection of operations that are used to specify a service of class or a component. Graphically, an interface is represented as a circle. It is expanded from an interface may be rendered as a stereotyped class with stereotyped interface names. Every interface must have a name that is distinct from these interfaces. Two naming mechanism: a simple name, only name of the interface. A path name is the interface name prefixed by the name of the package in which the interface lives presented. Operation: to distinguish an interface from a class, prepend an I to every interface name. Operations in an interfaces may be adorned with visibility properties, concurrency properties, stereotypes, tagged values and constants. Interface don't have attributes, interface, spam model boundaries, and it does not have direct instance. URL stream handle, open connection, pass URL, set your directional for operation stereotype. Understanding an interface. In the UML, you can supply much more information to an interface in order to make it understandable and approachable. First, we may attach pre and post condition to each operation and invariant to the class or component as a whole. By doing this, a client who needs to use an interface will be able to understand what the interface does and how to use it without having to dive into implementation. We can attach a state mission to the interface. We can use this state mission to specify the legal partial ordering of a interface operations. We can attach collaborations to the interface. We can use collaboration to specify the accepted behavior of the interface through a series of interaction diagrams. Interface relationships. An interface may participate in generalization, association, dependence and realization relationships. Realization is a semantic relationship between two classifiers in which one classifier specifies a contract that another classifier guarantees to carry out. Types and roles. A type is a stereotype of a class used to specify a domain of objects together with the operation applicable to the object that type. To distinguish a type from an interface or a class, preferred as to every type. Role. A role name indicates a behavior of an entity participating in a particular context, or a role is the face that an abstraction presents to the world. For example, consider an instance of the class person. Depending on the context, the person instance may play the role of mother, comforter, payer of bills, employee, customer, manager, pilot, singer and so on. When an object plays a particular role, it represents a face to the world, and clients that interact with it accept a certain behavior depending on the role it plays at a time. Thank you.